Hi, good morning. My name is Damilola, and I'm presenting a midterm presentation for Geo 2029 Civic Engagement Initiative. I am going to talk about the part one and part two of this project, while my colleagues will talk about the remaining. Our purpose for our purpose is to build an integrated data pipeline and visualization platform for Toronto voters' participation trends across time and geography, also empowering communities and researchers with actionable insights. This project this project originally started by per team for zeros and one. It's now a complete rebuild with fresh data sets, updated tools like Python and Tableau, um, and also we're looking at a modern architecture as well. For the part two of this project, we're looking at we have also collected data. We've collected voters' data and map shape files for municipal. And for municipal, it was from 2003 to 2022. And for provincial, it was from 2003 to 2022. And for federal, we collected from 2023 to 2021 elections, focusing mainly on Toronto. We also created a data inventory sheet with metadata and alternative source details as well. In the preliminary analysis, we used pandas and geopandas to pre-process data. We integrated CSVs with shapefiles and created basic visualization while identifying some inconsistencies as well. We were able to redefine our scope, shifting from a legacy Shining R code base to Python and Tableau, as earlier mentioned. Also, restarting the documentation from the scratch as well. We have standardized the data sets, removing redundancies as well, and also retaining the key attributes like word and also percentage voted as well, while preparing them for visualization. I would take it. My colleagues will take over from here. Thank you.
Good afternoon, Professor. I'm Rishi, and I'll be walking you through the technical works that we have done in our project so far, which includes data gathering, basic data analysis on the gathered data, and then data cleaning and some visualizations. First of all, I would like to show you the data inventory that we have created. We have listed all the um, data sets that we have gathered from the internet, uh, mostly CSV for the voter turnout data, as well as the save files for the maps for all the three levels of elections in Canada. So next, I'd like to show you the basic data analysis that we did on the uh, preliminary data that we gathered. As you can see, it has lots of rows that we won't uh, use in the project. So we separated data rows, total uh, subtotal rows, total of the wards, and global total, which are not necessary. So we did some conversion, converting the key columns to numeric, so it will be easier for handling commas and empty values. We handle missing values, and as you see, we did some grouping by wards for ward level descriptions, um, and then some visualizations. As you can see, the average turnout by the ward numbers and the school board support distribution. These were just in the data, uh, not necessarily needed for the project. And as you can see, here is the data after the pre-processing. Same for the federal data, but we had to filter it out to 25 writings of the Toronto city. So as you can see, we're only keeping the relevant columns, and as you can see, we have done some preliminary analysis like summing up the columns, and as you can see, the overall turnout is 58.4%, and the top five ridings by turnout percentage, as you can see, this has been visualized. Don Valley West has the highest turnout, as you can see from the data. And then after we gathered the map data, we integrated the earlier CSV files with the voter turnout data with the map. And as you can see, this has been visualized here. The intensity of blue shows those uh, wards have, those electoral districts have the highest turnout values. Um, as you can see, we used Folium to visualize it interactively. Uh, it can be hovered around to see the turnout of its electoral districts. Same for the municipal map. We integrated the early collected CSV files with the map, wards, and subdivisions. As you can see, we have loaded the save file. We are extracting the ward and subdivision from both of the files, and basic visualizations as before. And using Folium, we visualized in an interactive way. At last, I would like to show you the data cleaning process. Uh, as you can see that we have lots of unnecessary columns. So we only want to, for this project, we only want to keep three of the columns, and we want to standardize the name of the columns in each of the files we have collected. So after the basic cleaning, like removing the percentage signs and then uh, trying to integrate the district numbers to integers and dropping rows with all three values missing, uh, as we can run this code, we can see the output CSV file, and thank you for watching my part.
Hello everyone, I'm Mustafa Al and I will continue with my other colleagues started. So now I will go over the tools and technology we used throughout this project for data processing and analysis. Our main tool was Python, especially using libraries like Pandas and GeoPandas and NumPy for data manipulation, cleaning, and special processing. Python allowed us to handle large amount of collection data set efficiently and automated representative steps. We also used Excel mainly for manual verification and a quick cross-checking for all the small data sets, especially when we need to confirm the code on the formatting, like which we wrote it, is it working correctly or not? So we do it on both sides and we found it is correct. Moving on data visualization, we relied on Tableau to build interactive dashboard. These dashboards help us map voter return across different words and writing and visualization trend over time. During development, we also used GeoPandas and Metropolis for geospatial visualization. This helps us verify map boundaries and ensure accurate joins before the final Tableau integration. Finally, for collaboration and documentation, we worked through the SharePoint as our central repository for dataset logs and deliverables, and we use Microsoft Teams for our internal communication while we use Zoom for our meeting with the client. I will go right now to part number 5, which is challenges and proposed solution. Like any large data project, we faced several challenges along the way. The first issue was missing provincial map 4 years before 2018. This limited how far back we could visualize turnout trends. To address it, we followed up with the election Ontario achieved and supplement missing area using open source map data while clearly documenting these gaps for transparency. Like to be clear, like the second challenge was a high data volume. We were working with roughly 20 years of election data at three levels of government. This created a performance issue, especially in Tableau. Our solution was to pre-aggregate data by word or riding level before visualization and apply optimize extracts filters to keep performance smooth. Lastly, we had data visualization complexity. Since multiple data sets were being merged, there were a risk of mismatch or duplicated work. We solved this by automating visualizing script in Python. We detect the ID mismatch and missing values before each integration. This saved a lot of manual work and improved our reliability. Lastly, we estimated theoretical cost of the project, provide a sense of its scale. Each of our team member, Hershey, Demi, Sayed, and myself contributed around 30 hours of work with the rate of $50 per hour. That's total 1,500 per person or 6,000 overall for the entire project. This estimate reflects the time spent on data collection, cleaning, analysis, and visualization documentation, essentially converting a full data pipeline from start to finish. My colleagues now will continue. Thank you.
All right. So my name is Sayed Hamza, and I'm going to continue the presentation with our current recommendations based on the data cleaning, integration, and analysis completed so far. Our focus is on improving the data quality, enhancing visualization with clarity, and maintaining strong communication with the clients to ensure alignment moving forward to the next stage of our project. Let's talk about the data quality and standardization. So one of our primary recommendation is to maintain the data standardization framework we have established. This means to continue using consistent column names like we have shown you in the last week was the ward, the sub, the percentage voted across all data sets. We should also validate each data set against official election sources, which we are trying to maintain their data integrity. And also the transformation steps should be logged in our data inventory sheet, which is a Google sheet shared with our client as well, to ensure transparency and reproducibility for future analysis on client audits. Yeah. So to talk about the visualization improvement, so our second recommendation that is related to the data visualization, we have found that using unified map layers helps visualize voter turnout across municipal and federal election more effectively, as you can see in the screenshots in the PowerPoint. So adding ear filters will allow users to interactively explore like different changes that happens over time, and we can use heat maps to highlight regions of low voter engagement as well. These improvements will make our dashboards on Tableau or in Python Jupyter Notebook more informative and visually compelling for both policymakers and civic engagement teams as our clients team as well. To talk about communication and collaboration, this is our third area for recommendation. We have had strong client engagement so far. We recommend maintaining this momentum with weekly progress updates so that we are up on our project timeline. To talk about recommendation of next phase, our recommendations are focused on expanding from descriptive analytics that we have done to more of predictive and prescriptive insights for the future. This will like elevate the value of our work from simply reporting what happened to more about explaining why it happened and predicting what might happen in the next elections. This is something, something we have discussed in our weekly meetings. To talk about advanced analytical goals, we recommend conducting spatial correlation analysis to understand how these socioeconomic factors does influence our voter turnout. We can use Python by applying some regression and clustering models to find patterns. To talk about technology, from a technical standpoint, we suggest a hybrid analytics stack that combines Python for pre-processing and automation, and we can also go with a Tableau and Power BI for visualization and story maps. So we would like to automate parts of the workflow as well. To talk about client value and deliverables, the next phase will be prioritizing the deliverables that provide clear view to our clients. This includes comparative dashboards that show differences between municipal, provincial, and federal turnout rates. These outputs will help the client design targeted strategies to improve voter participation and more of civic engagement outcomes. Now let's talk about the last part, which is the conclusion. So I'll be giving you a little idea of the summary of achievements we have done so far and the impact and future outlook. To talk about, to summarize, our team has completed comprehensive data collection covering elections from 2003 to 2022 at all levels, whether it's municipal, provincial, and federal. We clean and standardize the data, documented all sort of transformations, and validated accuracy with external sources. The client has approved our data sets, and we got an updated email today as well about it. Talking about impact and future outlook, so the work we have done so far forms the foundation for a data-driven model for this civic engagement project. Our future focus will be on integrating social demographic data to uncover the deeper causes behind voter participation patterns, and the insight will generate directly support for policymaking in future if they're interested. So that's from my side. I'll